It's great to have that love when you're doing something that's just so hard. Every day, you're just getting battered down. Oh my God, now this.
Erum, what's going on?
It is going on, Karl. So many exciting things. We had a great weekend this past weekend, which was a little bit interesting. Super cold, super hot. How did you like your weekend?
So listeners of the Grow Everything podcast, you know that we record in New York City, and it was 80 degrees on Saturday. So it was a beautiful day. And then now it's back down to 40. It is spring. But I went to the beach and basically watched a seal for about 4 hours. I watched people come and look at the seal. I watched park rangers come and keep people away from the seal. I actually walked up to the seal, which is a really stupid thing to do. Afterwards, I learned that seals are extremely dangerous and they will bite your hand off. But it was incredible to just sit there and watch the seal sunning itself, which apparently is very normal seal behavior, sunning itself at Jacob Riis Beach. There was a couple of people who just freaked out. They're like there was a woman, she's like, my dad's a biologist. No one should be near here. And then the park rangers told me that the law is actually, you're supposed to be 3 school buses away from a seal.
Oh, wow. Good to know.
I had no idea.
Yeah, you shared a picture and it was beautiful. It was so shiny. I mean, I think it's because of the sunny day, but the sun reflecting off its coat, I was like, that would make a nice jacket. Snap.
I know. Who is out there growing seal fur?
Yeah.
Because I remember those images many years ago that started the PETA protests of people going up to Canada and clubbing baby seals
oh my God.
for their fur.
Oh, God. Yeah. I'm just kidding, guys. You know that I do not want any seals to be harmed for fashion. That's the worst thing. But yeah, and you're telling me, what was it called? Seal finger or something?
Seal finger. Seal finger is apparently very common among people who work with seals because a seal will bite your finger off. I mean, these are wild animals that eat fish in the ocean. So It's no surprise that their teeth are sharp. And this thing, it looks like such a cute little puppy. And when it looks at you and comes towards you, and I was like, oh man, you're so cute. I don't think I should be near you. And then I did the research and I was like, I'm an idiot.
Yeah, that's me and the swan in Prospect Park. So beautiful, and you're attracted to it, and you go closer and closer, and then it starts freaking out at you. But that's a me problem, not a swan problem. It's not a seal problem. It's a us problem.
Yeah, nature is all around us. We are here to talk about growing everything. And I think the swan and the seal are just reminders that there are wild animals out there, and proceed with caution.
That's right. Nature's all around us, and AI is also all around us these days. We've been chatting away, just asking questions, figuring out the best way to use AI in a way that keeps our deliverables strong and not dilute our real intelligence, RI. But we've been figuring it out. You were sharing a very interesting story about how we should be using AI.
Yeah. So when I talk to people about AI, people who haven't used it, I was like, you just have to remember it's stupid. And as much as it knows and as smart as it is, it really depends on you as a user. But this guy, Brad Reed, has a podcast called Inside Creative Writing. And he said that you should think of AI as being like Michael Scott of The Office. And the reasons for that are AI always wants to be liked more than anything. It wants, when it answers you, it's always polite. It tells you how great you are, how insightful you are. It will never admit it's wrong, again, like Michael Scott. It does just enough of a good job to not get fired, which is true. It even warns you AI is not always accurate. It overestimates its abilities. And I think we as humans overestimate its abilities at this point. And it always tries to impress you. Again, it's kissing up to you and showing you how smart it is. So very much like Michael Scott of The Office. In the show notes, I'll make sure there's a link to that podcast, but also to a LinkedIn post that talks about the same thing.
Yeah, that's incredible. It's so accurate. I mean, what a genius comparison. I totally get that. When you told me, I was like, yup. And I feel like there's a meme that could be generated. Maybe it's in the LinkedIn post, but my friend has a daughter who's 10 years old and she can play the Office theme song on the piano. It's so cute. But we're not the only ones using AI. A lot of world leaders have been using AI. What have you seen on that front?
It came out in the news that apparently world leaders are using AI for advice, which I thought was just hilarious because, again, here we are, we're trying to be smart about the use of AI. We talk about biologists using AI, how AI is going to transform biotechnology, and thinking about its effects on policy and stuff. But right now, it's still dumb. So I don't really know if I trust world leaders who are using AI for advice. We also are recording this just a few days after the internet went wild with the ability to giblify, just days after people had giblified all sorts of images. And it went down this rabbit hole of things are really cute at the beginning. And then the next thing you know, there's all these horrible images popping up that are in that beautiful comic format.
Mm-hmm.
So it's in the news.
Yeah.
You know, what can I say?
I actually think it's a good thing that world leaders are using ChatGPT just to help them frame ideas more holistically and not just look at one part of policy for their own interest, for their own political or economic interest, but being able to maybe look a little bit more objectively at different policy. And I'm bringing this up because I remember when ChatGPT just came out, and everyone's talking about AI regulation and what should policy look like. And there was this congressional meeting about it, and everyone's just talking over each other, and all this resources were being poured in to try and figure this out. Meanwhile, I just went on ChatGPT and I was like, create a list of AI regulations and policies that would help.
Remember.
Yeah. And it came up with some really great suggestions. They might not be perfect, but it was a good starting point. So hey, if world leaders need a starting point to come up with global peace, go for it. I'm all in. I'm all about it. You and I are like, look, if we can gather the world's intelligence, all of human intelligence and biological intelligence and compute intelligence, and AI is delivering it to us in a way that makes sense to us and better, let's go for it. Let's let the AI rule us. It's okay if it's benevolent and giving us suggestions to make the world a better place. Why not?
Yeah, I'm not sure I'm ready to have AI rule me, but
it is. It's a little too late.
In a way, it does already. And I think probably a good third of one half of my day is spent in a chat window. If I'm not talking to a client or working on client work, and even when I'm working on client work or working on the podcast, there's now AI has become part of the workflow.
Yeah.
And I don't mind it. When I initially started using it, I was really using it as more of a sounding board to volley ideas back and forth and to make my thinking stronger. I feel like I still do that a lot. I rarely am satisfied with the first answer that I get back. But I think for people who are getting used to it, again, I approach it as an idiot or as I approach it like Michael Scott of The Office.
Yeah, that's exactly right. You got to test it out and see how to use it to make yourself better. I had mentioned I went to this AI Emergence Summit and I met this amazing founder and I was speaking with her about, what does your company do? And it's really technical in regards to helping companies leverage AI better. So it's like a meta AI product. But she was saying that she uses AI to help her do sales. And she actually uses the audio modalities. So she's talking to AI and asking it, I was like, I'm going to sell my product to you. Tell me what you think. Ask me questions where you think that I'm missing. Let's have a sales conversation. So she's training herself on how to sell her product using AI in a conversational way. While she's driving, she has whatever platform she's using on, and it's a conversation. And
that's great.
Yeah, the way she's explaining on how she's training herself to be a better salesperson was incredible. I'm like, that's really cool. And the new modality, right? I think a lot of people have been, I don't know the numbers, but I'm just assuming that a lot of the AI interactions are text-based. I'm curious to learn how much is audio, but I think it's a cool thing. And after audio, it's going to be video. Being able to have AI evaluate your behavioral characteristics, your body language when you're speaking. And I think it'd be helpful for a lot of people that might have trouble with that. People that might not have the charisma easily on. They are like CEOs and they're trying to be able to create a relationship and connection with another human to be able to offer value to them on what they're creating, which is sales. It's going to be exciting to see how AI is more utilized for business.
Yeah, I totally agree. Should we talk about biology a little bit before we get into today's podcast?
Yes. AI and bio, that's the world we have to live in now. But yeah, so what about biology? What else have you been seeing out there?
So news came out last week that MIT is growing human-like muscles. There's been a lot of talk about soft robots. robots that are more like a caterpillar or like a snake. This stuff pops up in the news every once in a while. And so it's really no surprise to see that MIT is growing human-like muscles. And I think the thinking is eventually, I mean, this is the stuff of science fiction movies or books, that you're going to grow humanoid-like robots. There is talk already about humanoid robots in the $20,000 to $30,000 range appearing on the market relatively quickly.
Yeah.
You also had a story on this too.
Yeah. Someone sent me a crazy video, and you guys have to watch this video. I'll put it in the show notes, but there's a company called Clone, and they had this really spooky, terrifying video of a humanoid soft robot, I guess, soft robotics that was twitching. It was all chalk white and it looked straight out of Westworld. And it was like moving, but not moving like a human, but almost spastic, because they are trying to focus on this muscle aspect, it seemed like. But the company is called Clone. Their product was called the Protoclone. I was totally freaked out. I thought it was fake, but this company does exist. I'll add it to the show notes. And I don't want to see it. I don't want to see humanoid robots. All robots should be made for a task. Our refrigerators can be more robotic. Refrigerators can make ice, it can make water, it can make other things maybe. Let's use that form factor. Build a robot for the task. Don't build a human. Humans aren't made to do certain tasks. Yeah, we're good at them with our fingers, but maybe they need wheels instead of legs. That's better. Just weird. I know the challenge with manufacturing oftentimes is, I don't know, like screwing caps on. Even then, I can still see that there's tools. In the world of shipping, they still need humans to do some aspect of it. Is that because the robotics aren't created yet, or there's just because it's too challenging? Or maybe they're like, we can't just fire everyone, and so we're just going to keep humans in this regard? Or I know probably for cell phones, it requires too much dexterity. Creating those robotics might be too challenging or costly. So humans are cheaper labor to do high dexterity work.
I think anything with manufacturing, in most cases, a robot could probably do.
Yeah.
Not everything. And I just read a piece about a household robot that basically works at night and is a lot more than iRobot. Not only does it vacuum, but cleans dishes, puts stuff away. I don't know if it folds clothes, but it's meant to do a bunch of this stuff at night. And those are pretty close to market, if not on the market already.
Are they humanoid?
So, no, I can't say, actually. I don't know what they look like.
Okay.
I think it was Packy McCormick of Not Boring who mentioned it in one of his newsletters. So I have to go back and look at the details. So stay tuned for that, listeners. But let's talk about today's guest. Today's guest is an old friend of mine. Erum, you've met her a couple times, Molly Morse. Molly Morse is the CEO and co-founder of Mango Materials. Mango Materials is a company that uses gas fermentation to produce a bioplastic, a biodegradable bioplastic. And the company actually came out of Molly and her partner's work while they were working on their PhDs. They ended up raising money. And I've watched Molly's journey over the years, seeing her every year at SymBioBeta, having a couple conversations during the year between meetings. I think with that, let's let Molly take it away.
Today's podcast is sponsored by SymBioBeta. If you're a Grow Everything listener, you know that biology is the most important technology of the century. You also know that we're huge fans of the SymBioBeta conference. I've been attending since 2014, and it's my favorite conference of the year. There's no faster way to get up to speed on synthetic biology and its impact across industries. This year, we're going to be joined by inventor Dean Kamen, futurist legend Peter Diamandis, and Brian Johnson, among many others. SymBioBeta is where biology meets opportunities. So I hope you'll join us in San Jose, May 5th through May 8th to see how biology is transforming every industry. To get $400 off, use the promo code GROWEVERYTHING when you register at symbiobeta.com. I hope to see you there.
All right, Molly Morse, Mango Materials. It's so great to have you on the Grow Everything podcast.
It's wonderful to see you today.
Yeah, great to see you. We've known each other for a while. I'm going to kick it off with a little bit of a provocative question. Methane is a greenhouse gas. It's one of the most dangerous greenhouse gases. It causes a fair amount of damage to the environment. And yet, Mango has chosen this to be one of the fuels for its microbes. We talk a lot about microbes here on Grow Everything. Why did you guys choose methane, and what are you doing with that methane?
Yeah, well, so methane is the carbon that society has. Essentially, wherever there's people, wherever there's living things on planet Earth, there's methane. And I might even mention that there is methane throughout the galaxy. So this is C1, single carbon, CH4. This is what methane is. It's all around us. And it's what we use as our feedstock to feed bacteria to transform that methane into an environmentally friendly alternative for plastics.
I want to know a little bit more about your background. I know you have a degree in environmental engineering, but what really sparked your passion for science and engineering? What was the thing?
Yeah, so when I went to college, I thought I wanted to be a math major. I wasn't familiar with engineering at the time, so I thought I wanted to be math. I was in undergrad, I think it was the first week of college, and I realized that in college, math is actually super theoretical. And I loved building things and how things worked. I went to my academic advisor and was like, oh, I'm not sure if I actually want to be math after all. And I talked to him, and he's like, I think you might want to be an engineer. So this is how I got into engineering. During undergrad, I actually took a class, I think it was called solid waste management, but we called it trash. I've always been interested in just what happens to materials when they're no longer needed. The fact that something could be on this planet for so long after we use it, like a single-use plastic packaging, just has always blown my mind. So I've had a long-term love for science and engineering. And just to fast forward the Mango trajectory, I ended up going to grad school. I was studying biodegradable building materials for temporary applications, either temporary housing or formwork. When you pour concrete, there's structural materials needed there. Became really interested in how we could make new materials that could be biodegraded, but could also have great functional properties, why you needed them. And that transitioned into an interest in how you could make these biocomposites, where you have natural glues and natural fibers to replace plywood. Then became, how do you make these glues, these polymeric materials? And then, to make a really long story short, found a love of PHAs, which is this naturally occurring biopolymer produced by nature. And I have two co-founders at Mango. We all have slightly different backgrounds, but there's a lot of parallel in our journey. And we incorporated the company based off of that inspiration.
And what was the trajectory between grad school and starting Mango Materials? When was Mango Materials started and how?
Very soon after. So we didn't incorporate it while we were grad students. And actually, me and one of my co-founders, we actually met at an anaerobic digestion conference.
As one does.
As one does, yeah.
Exactly. We love anaerobic digestion. We're both just super passionate about methane. And so we met there when we were grad students. And both her and I had other jobs when we graduated with our PhDs. My third co-founder, Allison, was, I think, a year behind in her PhD compared to us. And so we had other jobs. I was consulting and kept thinking back to my PhD work. Saw a lot of other people in Silicon Valley starting companies with these ideas. And our idea, if we should call it, was very early, very science intensive. But we knew it could work. We knew you could take methane, feed it to bacteria, and make this polymer inside their cell walls. We knew that foundational science was part of my PhD work and my co-founder Allison's PhD work. So we knew that was possible. We saw these other people starting companies and we're like, we have the foundational science. Let's start a company based off of this. How hard could it be? The three of us consulted for a bit. We all had different things. Allison got her PhD granted. And then our very first funding was a grant from the National Science Foundation, an SBIR grant, Small Business Innovation and Research. It was $150,000 US. We thought it was so much money. It was for 6 months worth of work. That's how we got incorporated. We hired our first employee. That was the start. It's been a huge journey since then.
Wow.
How long has it been, Molly? I mean, just to kind of give people a sense.
Allison and I have been working together for almost 20 years, if you consider when we first met as PhD students. So yeah, we've been working together for 2 decades. Mango Materials itself, our very first funding came through in 2012. So it's been more than 10 years. And when we started, we were a science project. And now we have a launch facility that's operational at a wastewater treatment plant with operators that run the fermentation system. And when we started, it was me and my two co-founders were sampling a little tiny bioreactor ourselves. And now we have a team that does it.
Yeah, I can't wait to hear the specific stories. I mean, it's great that you have all this experience and you had the time to really think about how your company can really have a good impact and see some of the impact by now.
Yeah.
And Mango Materials, so your process is a carbon negative biomanufacturing process.
Correct.
Could you walk us through how converting methane into PHA sets a new benchmark for sustainable manufacturing?
Sure, happy to. So the methane that Mango Materials currently uses is from an anaerobic digester that's part of a municipal wastewater treatment plant. So this is in Vacaville, California, and it's just how all over the world water is treated. There's an anaerobic digester, and part of the byproduct of cleaning water using anaerobic digestion as a step is the production of methane. It's just what happens to the carbon. And you can use this methane for other things. It's often just flared. So the methane at the wastewater treatment plant would normally go through a candle flare. Instead of that, we partner with the wastewater treatment plant to have access to the site and have access to the methane feedstock. We have a pipe that comes directly off that pipe that would normally be going to the flare. And instead of flaring, we take that pipe and feed it into a tall, deep tank that's full of water and where our bacteria live. And the bacteria, like me or you, if we're to eat a lot of chocolate or something, we would get fat. These bacteria, instead of eating chocolate, they eat methane gas. It's their carbon source, their carbon feedstock. They eat the methane and they convert it to their carbon storage mechanism, which is a PHA, stands for polyhydroxyalkanoate. It's this naturally occurring biopolyester that's inside their cell walls. It's how they've evolved to survive famines, similar to us getting fat. It's a similar process. And so they've accumulated this biopolymer inside their cell walls. We harvest that biopolymer, comes out looking like a white fluffy powder, and that's one of the key ingredients for the pellets that we then sell onto the market. Instead of having this methane, which is a potent greenhouse gas, like you mentioned, instead of having it be flared or vented in some instances, we feed it to our bacteria to make materials.
Yeah, I remember, now it must have been 4 or 5 years ago, you were wearing one of the bracelets that was made from the material. And I was like, oh, this is cool. And it's real.
Yeah, and actually, I'm not today. This sweater is not from PHA, but I actually have a sweater made out of PHA fibers. Generally, our material is going into pellets. So pellets is what we ship. And generally, it's going into a hard good, an injection molded, something like this, or something little like toys. These are little injection molded figurines. Mm-hmm. And we don't make figurines. We don't make packaging. We make pellets that get melted by someone else to make things. But you can also have a different grade of pellets that gets melted to make fiber that could go into apparel. So I do have a PHA sweater. Or yeah, actually I have a shoe upper. So in this case, the pellets get shipped to someone that makes the fiber gets shipped to somebody that gets knitted. It ends up in a shoe upper. It's like a huge, complicated supply chain, but we make the pellets.
Okay, just so our listeners who aren't seeing the video know, Molly held up a test tube that looked like it was full of little white pellets. And then she held up basically like a little pot that you would have a cosmetic product in. Yeah. I think those are usually made out of a plastic or glass. She held up a little toy like a rubber ducky for a bathtub. Yeah. And then also a white shoe, looked a little bit like a Tom sandal kind of shoe, woven. Yeah, it's like very cool.
Upper mesh of a shoe. Yeah.
Yeah. So going from the lab, I think, again, when we first met, you finally had this little bracelet. That was one of the first products. But from a lab concept, going from these benchtop bioreactors to a full-blown facility is a challenge. It's one of the things we talk a lot about here on Grow Everything. We've had a lot of people come on and talk about different ways to biomanufacture goods. But for you and Mango Materials, what were some of the challenges, either technical or operational? You're laughing at this question that you encountered to go from the lab to the full-blown facility. And how did you guys overcome it? What did your team do?
We're still going through it now. There's constant challenges. Right now, I don't know, we're building a larger facility and they came back something about the fire suppression system. They need something else, the city does. And no big deal. We can get the engineer to do something for the fire suppression system for this. It's literally a storage shed. It's like, what? Anyway, I'll spare you, but it's like, this is
what we need to know.
Yeah.
Okay. When we started, when it was the three of us, just sampling the bioreactor, and we would do things like 24/7. Me and my two co-founders, we would do this stuff in the lab ourselves, holding pipettes, doing the monitoring of the gas. So we feed methane and oxygen. Our bacteria also need oxygen. So this is actually an explosive mixture. We do gas fermentation, which is, I know, not completely unique to your cohort, but in terms of the world of fermentation, very few groups are doing gas fermentation. So this is a whole different mass transfer feeding system. Most groups take sugar and feed sugar to bacteria to make stuff. We feed gas. So when we first started, how do we get enough gas? Mass transfer. How do we make sure the bacteria work? Okay, Anne and Allison, you sample at 3 a.m. and 5 a.m. I'll do midnight. that was our life. It is completely different world right now. And the three of us, our three co-founders, all have different areas of the business that we're focused on. We're kind of like engineers and very formulaic about things. But now it's been quite a journey. So we're talking about having a partnership with a municipal city. We need rights to the land and the feedstock. We need to work with the planning department. We need to work with permitting. We need to hire people. We need them all to follow the same standard operating procedure, the same SOP to make sure the bacteria grow in the same way. And if something funky happens in your process, you need to have the system set up to be able to analyze what's happened. And that's a very different skill set than someone who can follow the same SOP again and again and again. Oh, something weird happened and you have foam coming out of this orifice. What the heck happened? That's a different skill set. So safety is number one. That is the number one and most important thing to us. And so that's part of our culture. So you never want to jeopardize on that. But being able to be flexible and nimble and solve the unique problems by also having a rigorous order of operations is not trivial. So it's been just a constant thing. And even today, we're trying to scale up and build a larger facility. We're introducing a new material. Like we didn't invent PHA, others are producing it. It was identified almost a century ago, but it's not widely commercialized. So there's so much going on here. So I could talk for an hour about the journey, or hours.
Yeah. Yeah. I'm sure some of our listeners who are also founders, some of the early stage, some of them are later stage, but I could feel them resonating with you. They're probably just like, yes, that also happened. But it's learning, right? And you have this design, build, test, learn system. That's engineering. This is why you're the CEO and founder of this company. I'm sure it's fun for you too at times.
Yeah, most of the time it's fun and it's very interesting. And sometimes it's like,
well, why am I doing this?
Yay, would be nice. I don't know.
That's awesome. But you're doing this for a reason. You're getting products out into the market. You're collaborating with some very interesting companies, especially with this wastewater treatment plant that you have in Vacaville. Some of your partners include Allbirds, Stella McCartney. Can you tell us how did these partnerships come about and what do you think is essential for successful future collaborations?
Yeah. So unfortunately for us, all the collaborations have been very different. I wish I could be like, you go to this one conference and you network on this one day and you collect all your customers, or you just put out some posts on LinkedIn. I was talking to a current customer I'm super excited about right now. I was talking to him this morning and I was just curious, like, when you originally found us, how did you originally contact us? He's like, Facebook. I'm like, serious? And he's like, you didn't know. Seriously? So at some point in the next few days, I got to go figure out, somehow you must be able to message Mango Materials on Facebook. I don't know where that goes. Figure that out. So that was a first. It's like, oh, Facebook. So, but going back to Tora, Allbirds, Stella, all really, really different stories of how they came to be, of their interests. There are some themes. I would say one of the things is having some sort of champion internally there. So somebody who cares about the material. This is a new material. I mean, now for injection molding, it'll almost always process successfully the first time. But when we were first starting, it might not. And we didn't know all the different levers. You have to do this 100 times so you know every little thing that'll go wrong. So you need somebody who's going to understand that this is a new material. There's innovation involved and they're going to be patient and not have a nervous breakdown if something didn't work, and they'll work with you together. So an internal champion is really important. Ideally, they're getting something very unique out of it so they can tell a unique story on the marketplace, or they have a unique customer demand that is really, really asking for this. And so that can pull the innovation through the supply chain. And ideally, in the capitalistic world we live in, everyone's somehow making money throughout the process. Mm-hmm. So those are just a couple of the key points I'd mentioned.
Nice.
Yeah, and I want to just add to that, Kristen, because I'm super curious. You're working with this wastewater treatment plant, and I'm sure that if I was in the wastewater treatment business, I would look at this and be interested in it. But talk about how that one came about. I could just imagine you guys pitch the wastewater treatment manager and they're like, what the hell are you talking about? You're going to take our methane that we flare off and turn it into something useful? Are we going to get revenue from that? What does it look like?
That's pretty much how it goes. Yeah. There's a lot of other things around it. They're like, oh, cool, we can get revenue from this. Do they have space? Are they flexible? The economic development agency of the city or whatever is often interested in some kind of job creation or what have you. So there's an interest there. They have this methane that they're flaring and we'll pay them for it. So that can be a revenue source for them that's of interest. We're definitely interesting and different. It's not like there's tons of groups going around talking to the wastewater treatment plants being like, can I locate a facility there to use your methane? They're not getting a lot of that.
There is one publication that everybody in wastewater treatment reads, and I just see the headline of you guys in there talking about what you do, and then the phone is ringing off the hook, and the next thing you know, the Mango Materials factory of container ships is out there being deployed.
Yeah, one day. And you have to go through all those cities and permitting and citing where you're located and how big the facility could be. The more methane you have, the more PHA you could produce, and where's that going and where's it being shipped. So we love wastewater treatment plant methane, and there's a lot of reasons for that. But there's methane from all sorts of landfills, agricultural facilities, abandoned coal mines release a lot of methane. There's a lot of stranded methane in just the natural gas ecosystem. Agricultural facilities often have vented methane, or they have manure or other waste that often could be utilized. It's a long-term dream of mine to use methane from an agricultural facility to make dairy packaging and close the loop on carbon that way, long-term.
That's cool. Yeah.
Yeah, that's
We
amazing.
like when people dream. That's one of the favorite things, just to think about the future. But we know right now you have investment, you have to get money in, you have to stay focused, get the thing done, in spite of all the different challenges that come your way. I actually have this very vivid image of a wastewater treatment plant outside Philadelphia, because I lived outside Philadelphia, and to get into the city, we drive over this bridge, and it always did not smell the greatest. And then you see the flares. I never knew what it was when I was younger. I'm like, why is there fire coming out of this pipe all the time? I never saw it not on.
Yep.
So if you want to go to Philly and that's your next plant, I highly recommend it. I mean, it's a great city, because now you're in Cali, but maybe you can buy coastal.
Yeah.
So now, I mean, I don't want to get too political, because we always want to focus on biotech, but it seems like in today's administration, we're moving into an era where environmental regulations are loosening a bit, and there's less focus on reducing greenhouse gases. Do you feel like that's an issue? What are the biggest hurdles for broader adoption of biomanufacturing and biodegradable polymers? Is there any pushback, or things are just going forward?
With the new administration, other things, it's a little bit of a rebranding, is what I would call it. And yes, you are correct of everything you said. I would also say that generally wherever there's people or living things, there's methane. And this is a wasted resource that could be used locally to make materials locally on demand. This is a way to have resilient economies.
Yes.
Also in the rural communities as well, often have access to this methane. So we could talk about local supply chains, the local production of materials, being self-sufficient. We are completely focused on biomanufacturing, and we use methane, which is a greenhouse gas, to make an alternative to conventional plastics. But there's a lot of ways that can go different directions, and that it's still core to Mango's belief in mission, which is part of our story as well. So we're just highlighting those other aspects of it now.
Yeah, I mean, I would think that it would be very attractive to any municipal. You said there's multiple places, but basically to be able to go into a municipality and say, hey, here's a way you can increase resilience and make some money, then at the same time do some good for the environment. And that becomes the tertiary or fourth message, whatever. And I would imagine it would be very attractive to people.
Yeah, and it's creating local jobs. And human health is also a growing concern around microplastics. The chemicals we're ingesting, that's becoming a hot button issue. And so that's something that we're inadvertently targeting as well. The concerns are a little bit shifted now.
Yeah. Well, you're not the only one we hear it from, but I think we wanted to ask that question specifically because we see regulations being loosened, but we also believe that that creates novel opportunities for companies if you're thinking that way.
Yep.
So one of the things, going back and doing our research on you, it'd been a while, you had this story about you guys doing on-demand 3D printing in space using your bioreactors. And we've had a number of people come on to talk about space. Most recently, we had Erica De Benedictis talking about creating these chassis microorganisms for Mars that would be used to create a bioplastic from Martian soil. So how did Mango Materials end up in this low gravity environment? And what are you thinking about in terms of how you might integrate your technology to produce sustainable materials off planet?
Yeah, so we actually met a group through some circuitous means. We met a group from NASA and ended up giving a presentation there where we learned about some of the NASA programs. So it was actually an STTR, similar to SBIR, but there is more of a academic type collaboration that we applied for. I can't actually remember what the solicitation was, but this spearheaded our initial work looking at this. And we're never a space first company, and we're still not. We're very focused on planet Earth. However, you can use space and microgravity to learn so much about your system. So I mentioned a little bit ago how we do gas fermentation, and that's different. Well, a big part of this is mixing. So we have methane and oxygen, these two gases, and you have to mix them. Well, if you don't have gravity, that really changes the scenario. So we can learn more about mixing and microgravity, and we can learn about how the methane can be dissolved and delivered to the organism because they need to uptake that gas in order for the process to happen. And then you can think through the other steps of your process thermodynamically. And this is really helpful on planet Earth. But when you can use these off-planet environments to think it through, and you have funding to do that, that is enormously advantageous to the commercialization of our technology here on planet Earth. That continues to be the case. I can't remember what year this was. It was a while ago, our first funding, and we continue to advance that. We did a parabolic flight probably a year ago, maybe less than a year ago, testing some of these various attributes. And so this has been an ongoing source of inspiration, collaboration, revenue for the company as we deploy. But really, we want our first big commercial systems to be on planet Earth. We're focused on your more stereotypical type plastic applications here. But yes, you can imagine a world, if we're going to deep space, how are we going to make our materials? We could just ship our freeze-dried bacteria there and make materials locally on demand with methane that's there, rather than shipping plastic pellets or every different type of plastic device you could possibly need.
And just to go back to the technology currently works, the methane is bubbled through water that the bacteria live in, right?
Yeah, essentially, yes.
Yeah, very simplified.
Yes. Yeah, that's right. Yeah.
Okay, so then how would it work in space? I mean, how do you bubble water or gas, methane through water if there's no gravity?
Exactly. So you have to use a different form of mixing. A lot of our work has involved membrane technologies of dissolving the methane. Longer term, there could be some interesting dry fermentation where you grow the bacteria in a different type of environment. They don't necessarily need to be suspended in water to grow. So that creates a whole host of potential innovation.
Amazing.
Yeah, I mean, you opened up a can of worms talking about space. Yeah, it's so phenomenal. I just really loved how you pinpointed the fact that you're using this space application as an exercise to be inspired to create new models here for your commercial activity on Earth. And it is a good exercise for others that are out there. I always tell people that I meet founders all the time, can you do this in space? Because then you can get some of that space money. Yeah. And then help them. Who knows if there's a true demand and someone maybe want to license your technology, or as you get bigger and you have the time, why not? Why not? If the money's there, go for it.
For sure. For sure.
And that parabolic flight sounds good. Were you on that? I mean, I'm sure you would tell us.
No, I wasn't. Okay. It was some of my colleagues. Yeah.
Your colleagues at Mango Materials were on that flight?
Yeah. Mango Materials. Yeah.
That's so
amazing.
Cool. Was there any video of that?
Oh, yeah. We have video. I think we have stills on our Instagram page.
Oh, I'll link to that. Yeah. That's really cool. I'll have to see it.
That is so cool.
Reminds me of that OK Go music video. I don't know if you ever saw it, but they do a whole music video where they just time everything on this parabolic flight, but it looks like they're floating on a plane. There's balloons that are filled with paint, and then bust them and the paint flies everywhere. I get motion sickness, so I don't know if that would be my jam, but it's fun to think about.
Yeah.
So right now, Mango Materials has a facility in Vacaville. That's what right now we're focusing on, getting that to be producing. What kind of scale are we talking about in terms of production? How much are you producing?
Yeah, so it's a 5,000 liter gas fermentation system that we have there. So that's the scale we currently work at. And the facility is up and running and operating. What we're actually focused on right now, though, is larger volumes of our formulated pellets. So often that means purchasing raw ingredients from others. So we'll actually buy PHA powder from others that's not made from methane. It's made from generally some form of plant type feedstock. It can be molecularly identical or very similar to what our methanotrophs produce from methane, but we're able to purchase this third-party material so we have significantly higher volumes. Because what we're really focused on as a company right now is getting more volumes of pellets into the market, getting more applications commercialized, because we need that customer pull so that we can ultimately build a larger methane fermentation facility that's much bigger than 5,000 liters. But that 5,000 liter scale is what we'll be at for the near term.
And how do you measure it in terms of pounds, liters, tons of pellets produced from a 5,000 liter facility?
So capacity is probably on the order of 20,000 pounds per year of raw powder if you were just to operate it. So it's not designed as a commercial production facility. If you're making 20 or even 100,000 pounds of material per year, and this is the raw powder, 100,000 pounds, that's a very small volume for the plastics industry. When we think of where we were a couple of years ago, we're super proud. But yes, so those volumes are just small.
Yeah, as you should be. And I'm just curious, it's been a while since we've had someone come on and talk about pellets. Have our audience understand, how do those pellets get turned into something, the things that you held up earlier?
Yeah.
Do you ship the pellets and they go into these facilities?
Yeah, so I love cooking analogies, even though I'm not a cook. But anyway, how I like to think of it is you have flour, and there's different types of flour. So you can have whole wheat flour, or you could have white flour. So Mango Materials happens to make one type of flour. Our bacteria, our methanotrophs make one type. Let's pretend it's whole wheat flour. However, what Mango Materials sells is the dough. So we have dough that can go into waffles, and we have dough that can go into angel hair pasta. And so there's other groups that sell waffles, and there's other groups that sell angel hair pasta, and they need different types of dough, even though it's pretty similar. You have flour and you have water and you have eggs or whatever the heck goes into the dough. It's pretty similar, just different ratios, and you can treat it a little differently. That's essentially what we do. And we ship the dough or we ship the pellets to all these other groups that make their different types of baked goods. So then they take the pellets, and if they're making angel hair pasta, you put it through a pasta machine and you pull out pasta. Well, if you're making fiber, you take those pellets, you melt it down, it comes out of a spinneret, and you get these fibers coming out. If you're eating pasta at a restaurant, there's a lot of different steps that ended up to get that pasta on your plate in the restaurant, going all the way back to the farmer that made the flour. So it's very, very similar for the plastics industry to have all those different steps. And maybe you want it to be colored or dyed or treated, or some kind of unique thing happens to your food or your PHA pellet to make it into that end good. So it can be a very complicated supply chain.
Got it.
So what kind of baked goods are selling the most?
Our favorite type is the waffles, because you can imagine if you have waffle dough, if you're Holiday Inn Express, you can make a waffle. It might not be the best waffle, but you can be 4 years old making a waffle at Holiday Inn Express, or you can have a very fancy one at a Michelin star restaurant.
Yeah.
Anyone can make a waffle. So we love small format injection molded hard goods. Similarly, if you want the perfect angel hair pasta, you probably can't have your 4-year-old at Holiday Inn Express making perfect angel hair pasta. It might not even look like pasta. It might just be the little gobbledygook coming out of the thing.
Yeah.
So there's more expertise to roll out the pasta at the perfect speed and the temperature. And then you need to maybe line up the pasta strands so they don't get all tangled. There's a whole thing about it. It's very similar. So our favorite is the waffles or the injection molded.
Nice. I love that.
Yeah, I mean, we had all these questions, Molly. I'm like, should I ask the Lego question? Which you've been asked many times.
Yes. I don't know what this Lego question is. Please ask it.
Yeah, well, people are always like, oh, well, Legos, why aren't you making Legos? I get this question a lot. I think that's where I was coming from.
Yeah, that's where I'm going. Yeah.
The answer is, and I also get this question from kids all the time. So Legos are very precision engineering of how they're made. So going back to the waffle analogy, they are the exact perfect waffle to the perfect crisp, made the exact same way every single time. They make these little bricks that snap together with this satisfying click.
Yeah.
And you can store them in different environments, in your attic, in your flooding basement for generations, and they can still snap together decades later with that perfect snap. So this is very targeted, pristine engineering with very, very specific mechanical properties that is part of their whole brand. So for a new material that melts a little differently, flows a little differently, We haven't talked a lot about biodegradability here, but that's one of the inherent benefits, one of the inherent attributes of PHAs. They need significant enzymatic attack. They need a lot of bacteria. They need soil and moisture in order to break down. If you have a Lego of this in your house, it's going to last forever. But if you keep it in your basement and it floods and there's soil down there and you never clean it for 30 years, it's going to degrade. So that's why I like little figurines that are more either single use, or often these things could end up in your cereal box and you collect them and you use them for a little bit and then they're gone. Applications like that tend to be more of a target than specific Legos, although it'd be fun to be part of the Lego vision. There's so much creativity. I loved Legos as a child.
Right. And the reason I asked you this question a few years ago is because they keep talking about how they're greening their supply chain. They're going to start making more Legos. And maybe they just need to say biodegradable as part of their new branding, or have a line that says biodegradable on it so that people understand that, yes, it's going to last for a long time. But hey, if you really don't want it, the easy way to get rid of it is to put it in your backyard, and it's going to fertilize your roses.
Yep, exactly. And pull nitrogen out of solution. Yeah, I don't know.
Yeah.
Put in your fish tank, pull some nitrogen out. Yeah.
Exactly.
Carl's harping on the Legos because he has so many.
Yeah.
No, not anymore. No, I've lived that. I do have very large containers of Legos. And I've had this conversation where when my boys were young, their grandparents pulled out the Legos. So it goes to what you were saying in terms of these things last forever. And so as we started to amass our collection, there already existed a collection that we had inherited. So as I watch what they're doing and they're thinking about the materials and getting to know you, that was always one of those things I thought about.
Yeah.
Yeah, same thing. My kids have Lego sets that were both mine and my husband's. And yeah, my husband had one of the early, I don't know, Star Wars something. Ooh. I'm not into Star Wars, I don't know, but he had something, and that's very sought after.
Right. The space ones.
Yes. Yeah.
Yeah. So you were talking about biodegradability. So we've talked about that a little bit with some other biomaterials friends. Can you talk to us and remind us about how biodegradability is classified? What is the testing? And I know it's a matter of days. Does it biodegrade in 60 days or 90 days? Can you talk a little bit about how mango materials biodegrades?
For sure. So there's two different things. There's biodegradable and there's bio-based. And they're completely not related, but people get confused about it. So I just wanted to mention that up front.
Yeah.
So bio-based is where the carbon in the material came from. So if you have rapidly renewable methane, or you have corns, or you have other kind of plant that is feeding something to make the material, that means it's bio-based. And you can use sugar as a feedstock to make something that is completely not biodegradable. And you can use ancient fossil fuels to make something that's completely biodegradable. So those two things are not related at all.
Mm-hmm.
But then we have the term biodegradable, which is actually very much a controversial term right now. I actually try to avoid it, but I do use it. But basically what biodegradable means is prone to enzymatic attack. It means bacteria, fungi can secrete enzymes that break this down. So if you have a polymer chain and something can be secreted to start to break that down, mm-hmm. that means something is biodegradable. There's a biological mechanism that can start to break something down. It might be really, really, really slow. Maybe it's 1% in 1,000 years. It's still biodegradable. But that's why when we say something is biodegradable, we need to say in what environment and to what extent. And there's a lot of things that influence that. So PHA is a family. There's many types. And like the most popular type is P3HB, poly-3-hydroxybutyrate. Anyway, it doesn't really matter, but it's very, very common. And most things on planet Earth have the ability to break down P3HB, including humans. If you start breaking something down, if you want it to be fully biodegradable, you want all the carbon that is in that material to be completely consumed, completely reduced to something like CO2, carbon dioxide, single carbon, C1 carbon, or methane, CH4. However, how quickly something biodegrades, it depends on the environment. If you're in the cold, deep sea Arctic, PHA is going to, and a banana peel is going to take potentially years to biodegrade. I mean, we sometimes find old ancient organics that are super old because they're in these unique environments. If you're in the Caribbean or in a backyard compost and it's warm and moist and lots of mixture and aeration, something's going to biodegrade quickly. And if you have something thicker, it's going to biodegrade slower than something that's thinner. So I like to compare biodegradation to cellulose and think of a leaf and think of a log. If you have a leaf and it ends up in this moist environment, the leaf's going to biodegrade very quickly, just like a thin film of PHA will biodegrade quickly. If you have a log and it's in a ship in the Dead Sea or whatever with no oxygen, you could have a log that lasts 1,000 years in the environment, just like you could have a big chunk of PHA. And I've said way too many words, but biodegradation ends up being really complicated. And to answer your question, yes, there are all sorts of standards that you can pass, and there's different ways to do it over different time periods. And there's the TUV, TUV, people pronounce it differently, Austrian standard for backyard home compostable. Okay. There's ASTM D6400. There's all sorts of different things. Maybe you get a checkbox or you get a logo that you can say this is biodegradable, but that just really means it passed this one specific test in this one specific environment. It also doesn't mean if you want your material to not last forever and you want your material to be compostable, which a compost facility is a place, it's a noun, a compost location. Biodegradable is a verb, it's something that's happening to the material. But if you want your material to be biodegraded in a compost facility, there is specific testing that material can go under that you get a label that says this is okay. However, to make matters really complicated, compost facilities might not operate the way that test was done. And so it is possible you got this test, yes, the material works, and the compost facility is like, hell no, I'm not operating under those conditions. That's a contaminant for me. When it gets even more complicated. But anyway.
Wow. Are there industry associations where you're talking to your peers and you're trying to figure this stuff out, or you guys are getting tips? I would love to know what that is like.
Yeah, there's a group called BPI, Bioproducts Institute, I think is what it stands for. And they're trying to spearhead the cleanup of some of this. And it's also hard, just going back to the compost facility for a second, that's a great potential, a great end of life option for a lot of things, whether it's food, green waste, certain packaging. But right now, the way standards are written, especially if you want to make organic compost, if that's your product, you're in the business of selling organic compost, there are certain rules. And right now, they're written in a way that perhaps PHAs or other materials, not just PHA, couldn't be used because it can't come into their facility and you still sell organic compost. So yes, there's a bunch of agencies, organizations, trade groups, and actually PHA companies as well. They're trying to assist with this because there's different rules by different states, by different countries. The compost facilities operate differently in different places.
Yeah. Oh my gosh. Wow. Well, you're amazing. I just love the fact that you have really concise answers. I mean, you've been doing this for a while. So you're performing, but you're educating, you're selling. It was great. So great to finally meet you too.
Likewise. I mean, it's hard. What we do is just so hard, but it's good to have a lot of love and a lot of support. And I know my co-founder was at an event last night and I was about, technical, nerdy people learning how to sell because we're working on that. And I don't know if they told her, they're like, one company is going to make it. We want yours to be wildly successful. So it's great to have that love when you're doing something that's just so hard. Every day, you're just getting battered down. Oh my God, now this. So
yeah, I always love running into you and just hearing the progress because you've been resilient. You took this idea. You guys have come so far. And I mean, we were trying to get you on the podcast pretty early on. It's even better now because of the progress. It's exponential. It's building. So thank you so much, Molly, for coming on. We really appreciate it.
Thank you for having me. It's been a blast.
Hey. Hi. A quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business. So Karl, what'd you think of that episode?
I love Molly. Like I said at the beginning of the episode, I love seeing the progress that Mango Materials has made. And the reality of what they're doing really is impressive to me. I love this business model where they can go to a municipality and say, hey, you guys have these gases that you're producing in your water filtration plant. Hey, why don't we buy that from you? we'll turn it into this plastic. We're going to create some value from it. And I think we're going to see that type of business model reproduce itself over and over again, because I think there's a lot of waste out there. And municipalities in general are looking for new revenue streams. I mean, in New York City, we're seeing they're ticketing everything. We're reporting this and they're making composting mandatory. If you don't compost, you're going to get a fine. It's onerous for building owners because it means that you have to enforce that everybody is composting. But the other thing that I just want to comment about Molly and her company is they're producing these PHA pellets. Julie Marsh of Sway also talked about this, and this was a revelation to me, was that these companies that are producing these alternates to plastic, they produce these pellets so you can basically put them into the existing plastic infrastructure, which means that you can put it into injection molding, you can put it into fiber production. And that's really what led to the collaborations that Mango Materials had with Allbirds and Stella McCartney, among others. So I thought that was really cool. Erum, you're the space expert. What did you think of the work that Mango Materials is doing with space?
Well, yeah, of course, I loved it. This whole idea of space biomanufacturing is incredible. I'd be curious to dig a little bit deeper into where they would be getting their methane gases from. I'm guessing it has to be from humans or some type of exhaust from the space station. I'm really curious about that, but it's a great leap forward. How could their technology work in space, not only for space flight or space stations, but going to Moon or Mars or elsewhere for the terrestrial applications? It'd be cool if Molly Morse got together with Erica DeBenedictis of Pioneer Labs, just having a project where all of our friends that are working in biomanufacturing come together. And I'm sure we will see them at SynBioBeta, which we will be talking about more throughout the coming weeks, as SynBioBeta is going to happen May 5th week, Cinco de Mayo week. But it's a good step forward. I would love to talk to her more about how does bioplastic manufacturing work in low Earth orbit or microgravity? Is it faster? I was speaking to someone recently, and they were saying that the results from working on pharmaceutical drug development in space revealed that there were faster reactions happening, faster crystallization, interesting formations in microgravity. So what does that mean for polymers? I'm excited. I'm excited for Molly. I know that her main goal isn't to work with NASA and work in space. These are great projects to reinforce the work that's happening on the ground. Obviously, great for marketing, great for their tech teams or product teams to stretch their imagination. It was cool. What else did you like about the episode?
I mean, I think we spent some time talking about Lego.
Oh,
and
yes.
I wanted to point out that Molly and I had long emails about Lego a few years ago, maybe more than a few years ago, because Lego had put out this news that they were going to start replacing their plastic with much more biodegradable plastic. And my question to Molly had been, is this the plastic that you guys make? Why is it so challenging for Lego to make their plastics biodegradable? And we had this long discussion about, if you think about it, you could take a Lego that is produced today and you could take a Lego that was produced 50 years ago. I don't know how long they've been around for, but I know that there's very old Lego at my in-laws' house that belonged to my brother-in-law, who's about 15 years younger than I am. You could take the new ones and they'll work with the old ones. And the old ones will still work unless they've been tossed out and like really abused, because the precision of the molding and the plastic that is used has these properties that allow it to last for a really long time. And they're engineered in a way that they're going to all work together. So creating a plastic for that is going to be biologically more friendly with the planet is challenging. Lego is trying to do that.
Yeah, materials that Mango Materials is making sound softer. She showed, which we'll have on YouTube, she showed us what she made. They're like very soft. There's different grades of plastics. Lego has a very hard plastic, and she was talking about it has that perfect snap. When you snap the Legos together, It makes that sound. But the materials that Mango Materials is like softer right now. Unless they want to make a soft Lego line, which I think they could do with the Duplo line, the Duplo blocks, which are bigger. Usually younger kids use those. I have a set of lots of Duplo blocks here at my house. So that might be cool for softer, even for like little babies. It could be interesting, but that's a whole new product line for Legos. And we know that big companies to innovate is a challenge, mainly because they have a well-oiled machine and they just want their machine to grow and make more money. Of course, they want to experiment and do right by nature and do right by humans. But if it comes at a cost to their bottom line, their economic bottom line, that's a bit more challenging. Not to say companies are evil or anything like that. It's just that they need a more systematic way of introducing new innovation.
Yeah, and Lego is considered to be one of the more innovative companies. I have a question. Erum, you're going to Copenhagen in a couple of weeks. Are you going to Legoland?
Yeah, probably. I mean, I went to Legoland in Dubai, but the Lego factory, right? They have a factory there. I'm all about going to factories now. So that, I want to go to the Carlsberg factory. I want to go to factories, and they all have their museums and their welcoming tour guides. I loved and still love Mr. Rogers' Neighborhood. I love the part where they show the behind the scenes of how things are made. And I want to see that with my own eyes. I think that's a fun activity to do when you travel.
Absolutely. Yeah. I think that's a great note to end on. Was there anything else, Erum, that we need to cover?
What a great episode. I really enjoyed speaking with Molly. Stay tuned for some exciting episodes. And this is the run up to SynBio Beta. We're excited to have them be a part of the Grow Everything podcast. They're our friends, not our biological family, but in a way, yes, biological family, because we talk about biology all the time in their family. So we're excited for that. But get in touch with us. We'd love to hear from you. Thanks so much for listening to the Grow Everything podcast.
That's the pod. Thank you.